In exercise, where we're going to be looking at an overview of the skeleton. We're going to look at how the bones are classified. We're going to look at the structure of the bones, and also included in this will be cartilage. Where do you find the different types of cartilage? For the skeletal system overall, the functions are for support, protection, movement. They are involved with both mineral and growth factor storage, blood cell formation, triglyceride storage, as well as some hormone production. The skeleton is roughly divided into two divisions or two parts. The axial skeleton is comprised of the skull, the vertebral column, and ribs. And then the appendicular skeleton, as the name implies, is comprised of the appendages, the arms, the legs, and how it is attached to the torso. So in this chapter, we're just looking at the skeleton in general, not the two divisions of it. And you can see that it is color-coded here by the placement in terms of whether it is part of the axial skeleton versus the appendicular skeleton, and then by the types of cartilage: hyaline cartilage, elastic cartilage, and fibrocartilage. In terms of the types of cartilage, you do see several different types and locations of them. Articular cartilage is that cartilage that's covering the end of the bones at movable joints. Costal cartilage, costal refers to ribs, so that is the cartilage that is attaching the ribs to the sternum. And then you have laryngeal, which is in the larynx, nasals with the nose. Both the tracheal and bronchial cartilages are with the respiratory system. Intervertebral disc, this is between each of the vertebrae. It helps to separate and cushion them and kind of acts like a shock absorber. The external ear, what you see as your ear, is actually cartilage. In terms of bone classification, they are classified as long, short, flat, irregular, sesamoid, or sutural. The four main categories of them will be these first four right here. The bone markings, this is where on the bone itself, there are different smaller structures. There may be like bumps, etc. And that's where the muscles and the ligaments typically will attach to. Things such as the tuberosity, the crest, the spine. Like I said, these are often where muscles are attaching to. It helps you with identification of the bones, and you will need to be familiar with them. This table does show a nice list of some of these bone markings, as well as what the description of them is, and you can see where some of the pictures may be of what they actually look like. So be familiar with it now, such as tuberosity. It's a very large, rounded projection. And so there's a tuberosity right here. The trochanter, which is only in the femur, it's going to be right here. There's a greater and a lesser one. It's a very large, blunt kind of process that sticks out. Condyles, epicondyles, etc. So you need to start learning those bone markings. I recommend learn where the bone is first, and then once you learn where the bone is, then go back and focus on what the various bone markings are, because it's not going to do you any good to know what a tuberosity is if you can't find the bone itself. Some bone markings are going to be helpful in forming joints. These would be things like the condyles, facets, or heads. And then some of them are depressions and actually openings in the bone. Like a foramen is an opening. It allows for nerves and blood vessels to be able to pass through from one side of the bone to the other. So once again, both in your lab book as well as in your textbook, you do have these tables that have them all lined up for you with the definition all in one place, pictures, examples of them. And like I say, you're going to have to learn the major ones of those. If we look at the gross anatomy of a long bone, the long bones typically are going to be found in the appendages. And so what you're going to have is what you commonly would be familiar with as the shaft of the bone. We call it the diaphysis. And then the epiphysis is the end of the bone, and you're going to have a proximal end and a distal end. Remember, proximal is closest to the point of attachment. On the end of the bone, in this bluish color right here, is the articular cartilage. That cartilage is found where two bones come together to form a joint, and it keeps the bones from rubbing bone on bone. You do have connective tissue. Well, the bone is also connective tissue, but you have this connective tissue membrane, the periosteum, as you see right here, which is on the outer surface of the bone. It basically becomes continuous to the articular cartilage, and then it's going to come down this way, and it is lining the outside of the bone, helping to protect it. Inside the bone, initially on the superficial layer, you're going to have compact bone, and then you will have spongy bone in the middle. That spongy bone gets its name because it's very open, it has multiple cavities in it. The bone is going to be growing essentially in this direction right here. So depending on where the pressure is coming from, you will sometimes have the bone growing and expanding maybe in one direction versus the other on the side, but it is also growing in length, as I just said. This is the medullary cavity. It enlarges as the bone is growing and large, and ultimately it's going to be filled with marrow. The epiphyseal line, this is the site right here where you have the active growth occurring. Excuse me. And we'll talk about how that occurs in a moment. So this is the close-up picture of the previous one where you can see the periosteum that does surround on the outside of the bone. That is what this lighter color is right here. The endostem is on the inner or the interior portion between the compact bone and the spongy bone. This is the compact bone right here. You've got the marrow on the inside of the medullary cavity. The periosteum is attached to the compact bone by the Sharpie's fibers or the perforating fibers. Because bone is very actively growing tissue, it needs to have a very good, strong blood supply, and indeed it does. And once again, you can see here that you've got the compact bone, the endostem, the spongy bone on the interior. It helps to make the bone lighter, and the compact bone is superficial. Ossification, which is the process of making the new bone, does occur in different zones on the long bone. First, the cartilage in the proliferation zone is going to undergo mitosis. And then you have the hypertrophic zone, which is where those older cartilage cells start to enlarge. Then you will have the calcification zone. This is where the matrix calcifies. Remember, connective tissue, the cells produce that matrix on the extracellular, and that's going to start to calcify, and then it starts to deteriorate. The cartilage cells are going to die, blood vessels will start to invade the cavity, and then you have the ossification zone, which is where the new bone actually forms.